Hi, and welcome to section 3, where you will be introduced to the Spark algorithms. In this section, we will take you through the existing machine learning API of Spark with very simple snippets. We will show you the basics of linear algebra with Spark and put it into action with feature engineering and dimensionality reduction. You will also learn how to pipe models. In a nutshell, you will get a sense of how the interactions with Spark will be, and you will be prepared for the rest of this course. It is not intended to be an exhaustive review of all functionalities. We will use simple examples taken from the official Apache Spark documentation to make it easy for you. Now we move on to the first video of this section that describes the machine learning algorithms Spark provides. As data scientists, we use many complex algorithms to analyze data. We often just need the high-level libraries without bothering about the implementation details. To make our life easy, Spark ships out-of-the-box complete solutions for distributed machine learning. We will briefly list the available Spark packages and highlight their differences. We will also show you how to import third-party libraries if Spark does not provide what we need. The mllib module is the home for Spark machine learning algorithms. It contains common algorithms, including classification, regression, clustering, collaborative filtering, and dimensionality reduction. It also includes APIs for basic statistics, lower-level algebra primitives, and higher-level pipeline. Historically, all implementations were done in the spark.mllib package. This package contains the original APIs built on top of RDDs, the resilient data structures. Nowadays, development is achieved in the spark.ml package on top of data frames. The ML package also allows us to build pipelines, which is not possible with the mllib package. In the next sections, we will use the generic term mllib for spark.mllib as well as for spark.ml. This generic term is intended to refer to machine learning and is how Spark users refer to any Spark machine learning library. I advise you to use spark.ml if the algorithm you need is available there. With data frames, you will have a flexible and versatile API as well as pipelines and model persistence. However, if the functionality you are looking for is only available in the spark.mllib, then, well, just use it from mllib. Mllib is still supported and maintained, so there should be no worries at all. For example, mllib can export PMML and ships frequent pattern mining, which ML does not support it yet in release 2.0. Okay, so now let's see some code and learn how easy data science is with Spark. The next paragraph uses the mllib package to load a text file and train a SVM model stored in the model variable. mlutils.load_libsvm file reads training examples stored in libsvm format. The data variable is now a RDD of labeled point objects that contains the features and the labels read from the libsvm file. Let's build the training and test dataset with a random split. Training will be 60% and test 40%. We can now run the training algorithm and build out our model with the SVM with SGD object. You have to specify the number of iterations and pass the training dataset. We clear the prediction threshold, so the model will return probabilities, so it will predict the SVM margin instead of a class. Finally, we use our model to predict with the test dataset and create a RDD with raw scores and probabilities. The binary classification matrix is then called to compute the area under the curve, also named AUC metric. The AUC is error 1, which indicates that our model does a remarkable job. In the next section, we will visualize a ROC curve. I am sure you will love it. This SVM algorithm is also available in the ML package. We will work on the same dataset, but with the spark.ml library. The process is quite similar. You define the number of iterations and you fit on the training data. You can see that the training is now a data frame instead of a RDD. Also, the code is more compact and more readable. Finally, you can print the coefficients and intercept. You also have access to model summaries and you can print out some metrics. After this brief modeling teaser, let's wrap up what Spark has to offer. Spark ships classification and regression. It supports classical linear model like SVMs, logistic regression as linear regression models like least squares, lasso and rich. It also supports decision trees, including random forest, naive Bayes, and a few other algorithms. Clustering covers k-means, Gaussian mixture, power iteration clustering, latent Dirichlet allocation and their variants. Corroborative filtering provides recommendations, and the algorithm used here is alternating least squares. And for more details, please refer to the official spark.mllib documentation on spark.apache.org/docs/latest/mllibguide.html. Now, if the algorithm you need is not available, you have two options. The first one is to use a third-party library, which has implemented the algorithm you need. To load that library in the Zeppelin notebook, you will have to go to the Interpreter menu and configure the Spark interpreter. You will add there the Maven artifact of that library. The second option is to develop that algorithm by yourself, which is more of a hassle. For this, you will need the lower-level linear algebra functionalities. We will discuss this in the next section. In this video, we have learned to invoke some algorithms provided by Spark.